Good day YouTube, welcome to mathgotserved.com. In this clip we're going to be going over our Accuplacer Arithmetic Prep series focusing on how to compare and order fractions and decimals. If you'd like access to the remainder of our review series, just look at the description for a link to all the tutorials that you will need. We're going to start off by focusing on how to order decimals. These are the steps that we're going to be using for the problem solving process. Step 1, you'll have to express all the given decimals with exactly the same number of digits. So in some cases you have a decimal that doesn't have as many digits as the others. In that case you just simply add zeros to the right of the number after the decimal point. Okay. Step 2, after expressing all the numbers with the same number of digits, using zeros when necessary, you align the numbers in such a way that the decimal point lines up, and then you can easily compare all the numbers vertically. Step 3, you then identify the place values of the numbers. You need to know that they're descending in order of magnitude from left to right. And then lastly, you just order the numbers starting from the leftmost column that has non-zero numbers. Okay, and then you just compare the order of the numbers starting from left all the way to the right. Alright, so let's go ahead and take a look at an example where we're going to apply the steps that we just went over. So for example 1, the task is to order the given numbers from smallest to largest. Okay, this is a typical Accuplacer question. Alright, let's say we have 0.015, 0.51, 0.105, and 0.15. So this is the question. Now, if you take a look at the numbers that we are provided with, you notice that some of them have 3 digits to the right of the decimal, and some have 2 digits to the right of the decimal. Okay, so what I'll do is I want to make sure I have the same number of digits to the right of the decimal. So we have 0.015, that's 3 digits, and then 0.51, and then I'm going to put a placeholder here, 0. If you add a digit to the right or to the left of a number, you do not alter the magnitude of that number. Okay, so you have that, and then the next one is 0.105. This is fine because we have just 3 digits to the right of the decimal and 1 to the left, just like every other one. 0.15 is just 2 digits, so we need to put in a 0 there so it matches the rest. Why are we expressing it in this format? Well, when we organize them vertically, if we have everything accounted for, it's easy to compare the magnitude of the different numbers. Okay, so what we're going to have is, let's put our decimal point is going to be right here. So for the first one, we have 0.015. Alright, so we have multiple columns going on here. So let's say we have this, we have the decimal point, and then we have the 10th place, the 100th place, and then the 1000th place. Okay, we're gonna label them in a second. So I have them spaced out like that, and then of course we have the ones placed to the left. And then let's take a look at the next number. For the next one, we have 0.510. Okay, 0.510. The next one we have 0.105. And then the last one is 0.150. Now what you want to note is that when you're going, when you're going from left to right, you are increasing. Okay, so if you're decreasing. So if you're going from left to right like this, it's decreasing. In the left direction, you're decreasing, in the right direction, you're increasing. Okay? So if we want to compare order of magnitudes, we're looking for the number that comes first, going from left to right, and then we'll start comparing. Okay? So if you take a look at this, all these are zeros, so we don't bother about it. We're going to move to this position right here. Okay? So this position here is after the decimal point, is called the tenth place. All right. Now let's go ahead and assign numerical values to our numbers so we can easily order them. So let's say this is the first number we're given, this is the second number, third number, and this is the fourth. So this is number 1, number 2, number 3, and number 4. Okay, so let's see which one is the smallest number. Okay. So if we look at the tenths place, we're looking for the number that's the smallest. The smallest number is 0. Okay? So since this is the smallest number, that automatically makes number 1 the smallest number. Okay? So we have digit number 1 is the smallest. Less than. Now what's next? You notice that 3 and 4 are equally smaller than number 2. Okay, they're both 1s. So since these two are a tie in the tenths place, what do? We have to advance to the next place value, known as the hundredths place. Okay? Now if you take a look at the hundredths place, we're just focusing on these two numbers only because they had a tie in the tenths place. What you notice is that number 4 has a bigger digit in the hundredths place than number 3. Okay? So what does that tell us? It tells us that number 4 is bigger than 3. So 4 is bigger than 3, so we have to put 3 first. So let's take that out. So we have 3, and then we have 4. And if we take a look at the tenths place, the biggest was 2, so 2 is the largest out of all the numbers. Alright, so these are the order of the numbers just using their index. So let's write down the actual numbers in order of magnitude. Okay? So from smallest to largest. So from smallest to largest, we have, so please don't confuse your digits, okay? Number 1 is 0.015. Number 3, 0.105 is next. And then number 4, 0.15. We put in the 0 there so we can easily make our chart to compare. So we don't have to put it in the final answer. And then the biggest is number 2, which in its original form was 0.51. Okay, so that's basically how you order numbers, order decimals from largest to greatest. The most important thing is how you organize them vertically so that you can easily compare place values in order to determine the magnitude of a number based on the value of the digits in each column. Alright, next we're going to take a look at how to order fractions. Okay, so when you're ordering fractions, first thing you want to do is you want to find the LCD of all the denominators. It's rare for the Accuplacer to give you a problem where all the denominator values are identical, because that would be extremely easy. Okay, so the denominators, you should expect them to be different. In this case, you have to find the LCD of all the denominators. And then after doing that, you express all the fractions as equivalent fractions, where all the denominators of all the fractions are equal to that LCD that you determined. After you have accomplished step 2, all you simply do is you compare the magnitude of the numerator of each of the fractions. And it is the numerator that will tell you how to order the fractions from least to greatest or greatest to smallest. Alright, so let's consider the following example. For example 2, we are going to do the following. Order the following numbers from smallest to largest. Okay. All right. Now, let's say we have 2/3, 5/8, 3/4, and 4/5. So in this case, you can clearly see that we're dealing with fractions here as opposed to decimals in the previous number. If calculators were allowed, you can simply find the equivalent decimal to these, and then it's easy to compare. But without calculators, we'll have to do this by hand. Okay. All right. So step 1 is we want to find the LCD of the denominators, the lowest common divisor. So for 1, we want to find the LCD of 3, 8, 4, and 5. So what is the LCD of 3, 8, 4, and 5? Let's use our LCD chart to determine the answer to this question. So 3, 8, 4, 5. So I'm going to make my the composite numbers into the product of your prime factors, and then we'll be able to determine what the LCD is. Okay. All right. So we have our LCD chart. Now what I'm going to do first is start with the number on top. We have number 3. Number 3 is a prime number, so the only factor is just 3 and 1. We don't need 1, it doesn't help. So put the 3 there. Now number 8 can be decomposed into 2 times 2 times 2. If you use your factor tree to decompose 8, 2 goes in a 8 4 times, 2 goes in a 4 2 times. So 8 written as a product of prime factors is 2 times 2 times 2. Okay, so we are going to have, let me make enough columns. So where am I going to put the 2? The 2 doesn't match with this factor here, so I have to put it over here. So 2 times 2 times 2 gives us 8. Now 4. If you decompose 4, as you can see here, is just 2 times 2. We have a match here, so we have a 2, and we have another match here. You can put the 2 down here. The last number is 5. This is a prime number. The only factor is 5 and 1. We don't care about the 1, so we just put the 5 here. Okay? Now, the LCD is basically the product of the numbers when you read them downwards. So if you have 3 times 2 times 2 times 2 times 5, that is the LCD. Okay, so let's go ahead and multiply it out. We have 3 times 2 is 6, and then 2 times 5 is 10. 6 times 2 is 12. 12 times 10 is 120. So the LCD of those three numbers is 120. Okay, so the LCD of, what are the numbers again? 3, 8, 4, and 5 is equal to 120. All right, we've accomplished the first task. Now, task number 2 is to express every single fraction as an equivalent fraction with the denominator equal to the LCD, which is 120. So step 2, express all fractions using a denominator of 120. All right, let's start with the first one. The first one is 2 over 3. Now, how do I make this an equivalent fraction with a denominator of 120? I'll ask myself, what do I multiply by 3 to get 120? Or you just divide 120 by 3. 120 divided by 3 is 40, so multiply the denominator and the numerator by that numerical value. Okay, so the answer here is going to be 80 over 120. Okay, 80 over 120 is equal to 2/3. Okay, now we have 5/8. What's the story there? We need the denominator equal to 120. 8 times what gives us 120? You can just divide. You can do your long division if you don't know it. 8 divided by 120. 8 goes into 12 1. 1 times 8, 8. Subtract 40. 8 goes into 45 times. 5 times 8, 40. 0. 15. That's the number we need. So multiply the numerator and denominator by 15. So you get the equivalent fraction whose denominator is 120. 5 times 15 is 50 plus 25, which is 75 over 120. The next one is 3 over 4. So 3 over 4, we're going to multiply it by a number, a version of 1, where the denominator becomes 120. So 4 times 30 will give us 120. So the same on the top and bottom. And then we will have 90 divided by 120 as the equivalent fraction of 3/4 with a denominator of 120. Last one, 4 over 5. What are we multiplying this one by? So 5 times what gives us 120? Some of you already know exactly what it is, but let's just assume we don't know and just use our long division. So 5 divided by 120. 5, it goes into 12 twice. 2 times 5 is 10. Take out a 2, bring down that 0. 5 and 24. 4 times 5 is 20. 24 is what we are looking for. So multiply the numerator and denominator by 24. You multiply it out. You will have 4 times 24 is 80 plus 16, which is 96 over 120. Okay? So we have accomplished step number 2. We see all the equivalent fractions with denominators of 120 that are equal to the numbers that we have. Alright, so we can now order them from smallest to largest. Okay, so which one is the smallest one? We're just going to focus our attention on the numerator. Okay, so the numerators will tell us because the denominator is already identical. So I'm ordering from smallest to largest. We have the first one. The smallest out of all the numbers is 75. So 75 is equivalent to 5 over 8. So 5 over 8. And then the next one, next to 75, is 80, 2/3. And then the next one after 80 is 90 over 120, which is 3/4. And then 96 over 120 is 4/5. So this is the ordering of the numbers that were given from smallest to largest. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for the upcoming Accuplacer, do give us a thumbs up. We'll really appreciate your positive feedback. If you have any questions about the contents of this presentation or any concept on the Accuplacer you need support with, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.